Hello, followers of my YouTube channel. Welcome to today's tutorial. Uh, Today we will see some information about this analytical hierarchy process, an Excel template or macro that helps us to get weights of different parameters when you are working with uh, different criteria. Okay. Therefore, actually, this macro is developed by this Jopel, alright, and this template is worked under Excel version of 2013. Okay, and the workbook consists of 20 input worksheets for pairwise comparisons, a sheet for the consolidations of all judgments, a summary sheet to display the results, and a sheet with reference tables, yeah, random indexes, limit for geometric consistency index, judgment scales, and the sheet for solving the eigenvalue problems when using the eigenvector method are involved here. But the main limitation for this Excel template is the maximum number of criteria here is 10, yeah, up to 10 parameters. You can only use 10 parameters. And the maximum number of decision maker or participants is not more than 20, rather up to 20, yeah. Therefore, we can limit our parameters in order to do different criteria, I mean different parameters. Therefore, we may provide some criteria, yeah, parameters. We can give comments, and we can get the weights, yeah, for each criteria. We will see it one by one, and there are some eigenvalues under the macro, yeah, lambda as well as MRE, and the consistency ratios are also available here. Yes, we can get this CR or PSI as well as GCI. Okay, you can get what mean MRE means. That means the mean relative error, and the geometric consistency index, ordinary inconsistency, and consistency ratio. Those are actually the statistical parameters that are that helps us to detect our judgment. Okay, our judgment is right or not. And there are some normalized principle for eigenvectors. All right, if you take those parameters, three parameters in y-axis, and should have to have under the column section as well, and you can give some values here, yeah, your judgments, and it puts the reciprocals of that means this one divided by this under this, and this one divided by this one under this, and the likes. Okay, so criteria 1 may be compared with two criterias, 1 2. Criteria 2 is compared with one criteria here, and the likes. So we can make say type of judgments in this Excel macro. Alright, so in the Excel you have an option to input your number of parameters or criteria, yeah, and as well we can provide some values. Your judgments are there, alright, yeah. Therefore we will see how it works. So to do this there is a tool. We can download this tool from this link, yeah. Actually you can download from this one, pmsg.com. You can simply download from this link, this zipped file, yeah. And under that you can get this the PDF as well as the Excel format. So let us open this one and let us work with this Excel in order to get weights of different parameters. So let me enable editing here. Okay, from the starting, here is a version. Yeah, the version is, this version is actually the 2022 version, and you can get it is revised multiple times from 2012 up to 2022. That means almost 10 years. Yeah, so it has a lot of modifications is done in this Excel template. So under summary, we have this analytical hierarchy process Excel version, all right, and we can, as it indicates, free web-based HTTP software on you can get from this link, as it indicates. Okay, you can simply write HTTPS and the like, and you can get this application or this Excel macro. And the number of parameters that you want to input should be written here. Okay, actually here is 2 parameters, therefore up to 10 you can input up to 10 parameters, but it is limited that using more than 10 parameters is impossible under this Excel macro. Alright, so here are the numbers of participants, 1 up to 20, and here is alpha. There is also the scale as 1. This means, that means linear, yeah. If you are selecting one under the scale, you are using linear, and if you use 2, that is logarithmic, and 3 in the likes. You see, therefore you can for this case let us select 1, yeah. And as well, here is also AHP value is 1 up to 9, yeah. 1 up to 9 values are selected on our criteria. We will see what those values mean. All right, and you can put your objective here, the author, and the date. Yeah, in such a way we can give the criteria. So let us provide the criteria. What are the criteria that help us to weight our work? You can also visualize using this graphical method. Okay, you can use also graphical methods. When you insert criteria, you should automatically get a graphical picture for those parameters. So let me for instance, let me use those parameters in order to do this example. Yeah, for instance, we have 1 2 3 4 5 6 7 8 parameters in order to do surface irrigation stability mapping. Yeah, so let me copy this one. Okay, here. Okay, so I have provided the criteria for this case. Yeah, 1 2 3 4 5 6 7 8 parameters. All right, therefore you should have to write under this section. Then the number of parameter here is 8. Yeah, 8 parameters, and you can see automatically we have this graph. Yeah, this graph, initially the weight for each parameter is equal. Yeah, therefore you should do some normalization as well as our judgments. We should incorporate our judgment, and the objective of this example, for instance, is irrigation stability mapping. Okay, irrigation suitability mapping, and you can leave the authors, or you can write. For instance, I can write as, okay, my name Van Damlak. Okay, and you can write also the date. Today is 1/28 2024, right? Therefore I have provided the number of parameters, the objective, as well as the author in date, and I have provided the parameters, 8 parameters, and automatically you can see also the normalized principal eigenvector here. Yeah, it is generated now. Yeah, therefore we have this. After that, proceed to the next sheet, line 1. Under this we have the analytical hierarchy process, and you have the objective with irrigation stability mapping, uh, and the only input data in the light green fields. Okay, input data are the light green fields. Okay, therefore you can have this space which is expected to provide our judgment. Now we have 8 parameters, and we can compare each parameter one by one. For instance, under column A we have the slope. The first parameter is the slope is compared with the other 7 parameters. Under column B, yes, the slope is compared with soil depth, soil drainage, the soil type, land is land cover, distance to the road, distance to the river, and soil stoniness. So for instance, if we can compare this slope with soil depth, for irrigation stability, which parameter is greater? For instance, let me compare the slope or soil depth is for surface irrigation. What is the best thing expected? Let me say the slope is greater influence than the soil depth. By how much? I can say that I will give 3, for instance. This scale is given based on your judgment, but those numbers means, for instance, if you are giving 1, yeah, if you are giving that 1, the 2 parameters are equal importance for your objective, and if you have given 3, the 2 parameters, that means the slope is moderately important than that of soil depth. You see, should have, I am saying that this slope is moderately important than the soil depth when I give 3. Yes, and if I reverse with this A to B, the soil depth is moderately important than the slope for surface irrigation stability mapping. Okay, so in such a way you should have to provide those scales. 1 means equal importance, 3 means moderately importance, 5 means strongly importance, 7 means very strong importance, and 9 is extremely important. But those even numbers 2, 4, 6, and 8 can be used to express intermediate values. For instance, if I give 2, yeah, which is between equal importance and moderately importance, I am saying, yeah, which is an intermediate between one equal importance and moderately importance. If I give 4, I am providing that it is between moderately importance and strongly importance. So in such a way you should have to provide the weight for each the scale for each parameters. All right, so the slope is compared with the soil depth in such a way. The slope is compared with the soil drainage. For instance, let me give us slope is greater by how much, between moderately important and equal importance, if I say. and automatically we can see the CR value here, consistency ratio value, because it governs our judgment. Okay, this consistency ratio governs our judgment, because it should be less than 10% to be our judgment is acceptable. All right, therefore you should have to automatically see this value. Okay, so you should have to provide in such a way for the parameters, and let me say that the slope with the soil type. In this case, soil type is very important. Let me assume by how much? By 5. Let me give us 5. And slope with land is land cover. Yeah, let me give us slope is important. By how much? By 2, for instance. And the slope with distance to the root, the slope is very important. Yeah, by how much? Uh, let me, yes, 3, for instance. Yeah, you see automatically it is increasing. Therefore, you should have to take care of that. The slope with distance to the river, for instance, slope, and by 3, yes. And the slope with soil stoniness, slope with 5, for instance. Automatically it is greater than 10%, and this is highlighted by red color. So you should have to work on those values when you are providing the remaining parameters. Okay, you should have to take care of. So we are comparing the slope with the 7 parameters. Yeah, and the other thing is you should have to compare the slope, the soil depth with the remaining 6 parameters. Soil depth with the soil drainage, soil type, the land is land cover, the distance to the road, the river, and soil stoniness here. So we should have to compare that. Similarly, soil depth is compared with soil drainage, and soil depth is very important. By how much? For instance, by 5, I can say, or we can say that equally importance. Yeah, equal importance. And the soil depth with soil type. Yeah, B is greater but more equally importance, or let me increase this one. Yeah, no influence. The soil depth with the land use, soil depth is important, and the soil depth with value of, let me give us 3, it is now increasing. Let me use as 5. You see it is automatically increasing. Let me use 2. Okay, between equally important and moderately important. In such a way you can feel those all things. Okay, should have to feel in such a way. Okay, now in a similar way I have given the normally my judgment here. You see, in a similar way we can compare the soil with the 6 parameters, the soil depth with the remaining 5, soil drainage with the remaining 4, or the likes, up to distance to river with soil stoniness. And the soil stoniness is by default compared with all the parameters: soil stoniness with slope, soil stoniness with soil depth, soil stoniness with soil drainage, and finally the soil stoniness with distance to the river. Therefore, we are comparing, or we have done the sensitivity analysis in such a way. Actually, this one is very important. We may get some additional softwares like space logics and other parameters. I mean, other tools in addition. Therefore, you should have to done those things in that model. So actually, this Excel version is very important in order to manipulate easily. Therefore, after you have provided such judgments, you can see the consistency ratio is greater than 10%. And this red color, this 3 to 1, shows us The inconsistency comes due to those three things. The first and the highly affected thing or judgment is this one. One is the highly affected judgment we can get from this note. Okay, for instance, you see this judgment is inconsistent due to those three things, and one here means the most inconsistent judgment is marked with one. This is highly red color is highly or the most inconsistent judgment, and followed by these two, yeah, and the third one is this one. Therefore you should make some correction on those uh, judgments in order to make your consistency ratio within the acceptable limit. Therefore, let us first do on the highly sensitive case. Let us see from the easiest one. For instance, the slope with the soil drainage, that means soil slope is greater than the soil drainage, and we have provided 3 here. Let us increase with 5, for instance. You see, actually this increases our inconsistency, and let us stay with this and proceed to the second one here. Distance to the road with the soil stoniness. Actually this road is very important for surface irrigation suitability, because we need accessibility for markets and the likes after we are producing our crops or other um, products from our irrigation fields. Therefore, this one is another parameter. And if you compare the road with the soil stoniness, we have provided our judgment as this one. Let me give a 7 for instance. And this one is also it increases our judgment. And let us use as it 5. And let me come up with this one, the river with the stoniness. Yes, let me use 3 here. Yeah, if I make this one is 3, our judgment goes to the first case, inconsistency goes to this one, the first one. Yeah, let me use as for instance 2. Good, our judgment is below 10%. Now all the markers are reduced, and let me reduce this one to 3. What we see here, let me use as 1. You see, if I compare the soil with the soil drainage as equal importance, yeah, so our consistency ratio is 8%, 0.8 actually, 0.08, and all the provided judgment or scales are acceptable now. And we can also see some decision matrices here supporting calculations. Decision matrix A, yeah, we can get this one, the ln of A for calculations of in the likes. You can get some the errors here. Okay, so we can get those informations from our output, and in order to get the final weight for the parameters, back to this summary sheet and go to under this the first one, so we can have an access to get the weight for each parameters. Okay, the slope has a weight of 40.7, the soil depth is 80.4, the soil drainage 6.2%, and the soil type, you see, highly covering portions of the stability or the weight is the soil type, which may be due to our false judgment, but it is still acceptable. Okay, and you can see the plot here. You can see the plot that help us to figure out in such a way. Therefore, I hope you have get an interesting tool which is called analytical hierarchy Excel version. in order to obtain the weights for the criterias. It also helps to determine the groundwater potential zones, flood areas, and also for different business tasks. Okay, so it is all about today's tutorial, and thank you for your watching, and don't forget to share and uh, to share to your friends. And if you have any question, please put it under the comment section. I will forward to your questions. All right, and have a nice time for today. Bye.